passing it on. It's like it'd been better if they just, I don't know, it seems like they broke it up so much. If you look at it, the problem here is that they gave Uncle Albert's arm span, I'll put UA, is 3 feet, and then Albatross's was 15 inches, so that it's hard to compare that when you don't have the same units, right? So what they were trying to get you to do here, if you look, does it make sense to say that their ratio is 3 to 15 or 1 to 3? 1 to 5. Like, should I reduce 3 over 15 to 1 over 5 and say, oh, the ratio is 3 to 15 or 1 to 5? No, it doesn't make sense because not the same units is all that they were looking for there.
Okay, cool.
Yeah, so this one ends up just being, kind of almost it's the wording in the book that's confusing. 28 says change Uncle Albert's measurement to inches and find the ratio of their arm spans and express the ratio in decimal form. If you want to know if two things are really proportional and you have a bunch of different fractions, if you remember what we did is we went ahead and divided them out and see if they are the same number, okay? So if you change Uncle Albert into inches, he was 3 feet times 12 inches, right, would be 36 inches. So what they're wanting you to do is take Uncle Albert, let me go over here, Uncle Albert, and make a fraction with Albatross now in inches, 36 inches over 15 inches. When you divide that out, if I've got your calculators, you might want to, there's something on my calculator. Okay, 36 divided by 15, that's not right. You get 2.4. Okay, so they're just wanting you to express it that way, and the reason they do is that now they want you in the next problem to change Albatross to feet. Well, Uncle Albert was 15 feet. Albatross was Uncle Albert was not 15 feet. 3 feet. Albatross was 15 inches. Isn't that like 1 foot and 3 inches? But if you want to write that as a decimal, that's like 3 out of 12, isn't it? So that's like equal to 1 foot and 3/12. That reduces to a fourth, doesn't it? 3 over 12. So a fourth is like 0.25. So Albatross would be 1.25. So now they want you to make another fraction with Uncle Albert to Albatross and express it in feet. So it was 3 feet to 1.25 feet. And then they want you to divide it out. Well, when you divide it out, you get the same thing, 2.4, that we got when we did it in inches. So, whether we expressed it in inches or feet, when we divide the ratio out that we get, we still get 2.4. So does it matter what unit I represent things in? No, as long as you're using the same in the comparison of them, right? So units just must be the same. Doesn't matter whether it's inches or feet, as long as you do the same thing. Because we get that same ratio there, 2.4 on both sets there. So that was what was going on in 27 through 30. The book just can find a way to make everything kind of confusing sometimes, just the wording of it. So anyway, if you look at 9, they want you to make a ratio out of AB to CD. Well, if you look at AB, isn't AB that length, isn't it 2D on top? If you kind of look over at that column, isn't from A to B, they mark that 2D, right? Mm-hmm. Okay, so now let's look from C to D. From C to D, that's 7D. And I can reduce that fraction by canceling the D's out. So it would be 2 over 7, okay? You kind of think that maybe this is going to turn up again, and maybe they're trying to get you to see a pattern, but no, there is no pattern that I can tell. Y'all tell me if there's a pattern, because I don't see it. If you look at 10...
So it's just asking you to reduce.
Yeah, you're just reducing the fractions is all that you're doing there.
No wonder I was thrown off.
BE, it's a half plus 7 plus another a half, so BE would be 8D, okay? AE is the whole thing, so if you think BE was already 8, I could just add AB in, that's 2 more, so you'd get 10D on the bottom, and then the D's cancel out, and 8 over 10, isn't that equal to 4/5? I don't see any relationship to 9, so I'm not quite sure why. I don't know. Y'all see anything? Anybody got any clue? I don't have a clue. AE is again the whole thing, and we just found that the whole thing was 10D, and they want us to divide it by D. So I divide by D, and I get 10. And again, why are they asking me to do this? I'm not sure. So I thought they were going to have some profound thing come out of this when I was flipping through. Sometimes I'll go, oh yeah, it looks like that maybe they're going to show you something with the, I was expecting something with the golden ratio because there's so much of that built into the Greek, things like the Parthenon. So I thought maybe the golden ratio is going to show up, but I don't see it if it's there. I don't know what's going on there. But if you look at like the ones in the 41, through 46, if you look up there at the notes, they're telling you the relative lengths of the strings to one another, at least in the musical scale that Pythagoras was looking at. So if you look at 41, they want to know D to E. And so you just take the 8/9 and you put it on top because that's what D is labeled. E is labeled 64 over 81. So now we got a complex fraction, right? So we just say 8 over 9. And we multiply by the reciprocal of the denominator, right? So it'd be 81 over 64. Let's see, 9 goes into 9 once. It goes into 81 9 times. 8 goes into 8 once. It goes into 64 8 times. So we end up with 9/8 as that ratio from D to E. I guess they're measuring. Did I do something wrong?
Well,
No, I got that for 41.
what I did was,
Let's see. Maybe we do another one of these. Looks like it's 44. From G to A, let's see, G is labeled 2/3. A is labeled 16 over 27. Okay, so I bet you could express, it's not quite cubed. We'll just go ahead and do the complex fraction method. 2/3 times the reciprocal of the denominator. Really? Okay. Well, 3 goes into 3 1 times. Who was that? 3 goes into 27 3 times. Okay. 2 goes into 2 ones. 2 goes into 16 8 times. So this one ends up being 3 over 8. I messed up. 3 goes into 27 9 times. So that ends up being 9 over 8, which is the same thing that we got for 41. Are you getting the same number every time? I'm just curious. Okay.
Oh, I didn't for 42.
Okay, so let's look at 42. E over F. Okay, E is 6.
and for 46. 46.
Okay. 64 over 81, and F is 3/4. They're having an interesting discussion. Was that Max? 64 over 81. Tell him that.
Okay, no, I know I learned this like a long time ago. When you have like the multiplication, when you're just multiplying factors, do you just multiply the denominator and multiply the top one?
Yeah, you multiply across the top and you multiply across the bottom. Yeah.
I mean, it's
It's
like
not just
cross
you.
multiplying.
No, it's
And I'm just like, what
not.
do I do?
You only cross multiply when you have equal in the
That's
middle.
what I thought, and I was so confused.
Now remember, you can simplify this fraction in your calculator if you don't want to multiply all that out, because I don't know if this is going to reduce at all. I'm not sure it will. 64 times 4 on top is 256, and 81 times 3 is 243. So if we divide 256 by 243, we get like 1.05, whatever, blah, blah, blah. I'm just going to do math and enter. It doesn't reduce. Is that what y'all got on 42?
Yeah, that's what I got.
46. Oh, wait, no.
That's 42.